This channel is specialized in solving FEA problems for civil engineers. Today I will solve several problems in fluid mechanics and hydraulics. So let me share my screen. Okay, question number 1 is about open channel. We have an open channel. We will know the dimensions. A rectangular cross-section open channel with width is 4 meters and depth is 2 meters. This is 2 meters. Water depth and width is 4 meters. And we know the slope of the channel bed. Slope equals 0.0005. And we know the roughness coefficient, Mann's roughness coefficient, N equals 0.015. So we want to determine the flow in this channel. Now, open channel questions are always solved by Mann's equation. So Mann's equation, Q equals 1 over N A R to the 2/3 S to the 1/2. So this is the Mann equation, which we can use now to solve for flow. Now Q is the flow, N is the roughness coefficient, A is the cross-sectional area, R is the hydraulic radius, and S is the slope, channel bed slope. So A equals, we have a rectangular channel 4 by 2 equals 8 meters square. And R, we know R equals the hydraulic radius equals A divided by P. So we know the A is 8. So we want to determine the P, which is the weighted parameter. So the P is, this is the channel. So this is the P. This is 4. And this is 2. So P is the weighted parameter, which is the area or the channel boundary that is in contact with the water. So P equals 4 plus 2 plus 2, which equals 8 meters. So R equals A over P, which is 8 over 8, which equals 1 meter. Area is meter square, P is meter, so R is in meter. So now we can go and substitute into the equation. So Q equals 1 over N is 0.015. A is 8. R is 1 to the 2/3. And S is 0.0005 to the 1/2. So if we do the math, then Q equals 11.93 meter cube per second. So this is the flow in the channel. It's very straightforward. The question, rectangular channel, is the easiest type of cross sections. I mean, to find the weighted parameter and the R. The next question, we have a hydrograph of 12 hours. The base of the hydrograph is 12 hours, whatever when it started. This is the time, and this is the flow. So the duration is 12 hours. And the peak flow is 10 meter cube per second. 10 meter cube per second. And we are required to determine the total runoff. Determine total runoff. So in a hydrograph, the total runoff is the area under the hydrograph. So here we have a triangle. We know the base and we know the height. We simply find the area of the triangle. So the total runoff is the area of the triangle, which is half the base multiplied by the height, which is, and we do unit conversion. So it is half, base is 10, 12 hour, and flow is 10 meter cube per second. So we multiply by 3,600 seconds per hour. Okay. So second with second cancelled, hour with hour cancels. So we have the runoff equals in meter cube. We have runoff equals 216. Yeah, we have to divide by 2. Okay. 216,000 meter cube. So this is the total runoff, which is the area under the hydrograph. If you have any question about these two questions, you can send me a comment to let me know in the comments. So the next question. This is an easy question. We have a rectangular open channel, again, with 2 meter rectangular open channel, 2 meter wide, and 1.5 meter high depth. And this is 2 meter. And the V, we know the velocity, 2 meter per second. We know the velocity in the channel. And we want to determine the flow. That's a very straightforward question. So Q equals VA. We know that the flow anywhere equals velocity multiplied by the cross-sectional area. So Q equals, velocity is 2 meter per second, by the area is 1.5 by 2. So this is 6 meter cube per second. Okay, that's a very simple question. So we move to the next problem. Now in the next problem, we have a rectangular gate 2 by 3 submerged underwater. Let me move it. We have a rectangular gate. This is water, the water surface. We have a rectangular gate here. This is the gate. It's 4 meters under the water. This is the top of the gate. So the top of the gate is 4 meters below the water. And the height of the gate is 3 meters. And the gate is rectangular, 2 by 3. This is the gate cross section. 2 meters by 3 meters. So we have a gate that is 2 meters by 3 meters submerged underwater. The top of the gate is 4 meters under the water surface, and we are required to determine the hydrostatic force acting on the gate. Now, in this type of a question, the rule is that the force, hydrostatic force, equals P, the pressure, force is pressure by area. So P at the centroid, let's call this P average. P average by the area. Now where P is the pressure at the centroid of the object, at the geometric centroid of the object. Now the geometric centroid of the gate is 3 meters. So it is 1.5 meter from here. .5 meter, this is rectangular, plus the 4 meter. So the geometric centroid of the gate is 5.5 meter from the water surface. So P equals gamma H. So P equals gamma, which is 9.81 kilonewton per meter cube. Multiplied by, let me, so P equals 9.81 kilonewton per meter cube multiplied by H, which is 5.5. Now F equals P multiplied by the area. That's simple. 9.81 by 5.5. This is the pressure multiplied by 2 multiplied by 3. This is the area of the gate. So if we do the calculation, F is the hydrostatic force is 323.73 kilonewton. So this is the simplest way for solving hydrostatic force on submerged object. The idea is to find the pressure at the centroid of the object. Then after that, to simply multiply it by the area. There are other ways to solve the problem, but this is the easiest and fastest way to solve it. Now, during the exam, the FE exam, you should be careful about the time. So you always should select the fastest way to solve a problem. The next problem, we have a dam with surface area. We have a dam with surface area equals 5 kilometers square. And we have evaporation rate. Evaporation equals 6 millimeter per day. What is we want to determine the evaporation, determine evaporation in 10 days. So we have the surface area of the dam, which is 5 kilometers square. And we have evaporation rate is 6 millimeter per day. And we want to determine how much water will evaporate in 10 days, the volume of the water. So we simply multiply the evaporation rate by the time. So we have water volume that will evaporate equals 6, and we do unit conversion. Millimeter per day. Since we want to have the answer in meter cube, so we divide by 1,000 millimeter per meter. So this is now meter. And we multiply by the area, which is 5 kilometers square. So kilometer is 1,000 meter by 1,000 meter. One kilometer equals 1,000 meters. So 1 kilometer square is 1,000 by 1,000. So 1,000 by 1,000. Okay, that's meter square per kilometer square. So if we do the calculation, the volume of the water that will evaporate in 10 days, yeah, we have to multiply by 10 days. This is the evaporation, this is the area, and we have to multiply by the time, by 10 days. So the answer is 300,000 meter cube. So this is the answer. The water that will evaporate in days, 300,000 cubic meter. If you have any question about this problem, please send me a comment. Okay, next question. We'll do one more question. Now we have a pipe of length 100 meter. We have a pipe L equals 100 meter. And the diameter is 0.2 meter. And we have Q flow in the pipe equals 0.04 meter cube per second. And we know the friction factor equals 0.02. So we know the length of the pipe, we know the diameter, we know the friction factor and we know the flow, and we want to determine the head loss. So for head loss in pipe flow, we always use the Darcy-Weisbach equation, which says that head loss equals friction factor L over V square over G. So we know the friction factor, we know the length, we know the diameter, and G is known, so we want to determine V. So V equals Q over A. So we know the flow, 0.04 meter cube per second divided by the area. We know the diameter. So the area is by D square over 4. So by the diameter, which is 0.2 meter, by D square over 4. So the 4 comes here. And okay, I don't have the, yeah, the velocity is 1.273. 1.27 meter per second. So now we substitute for head loss. Equals F, which is 0.02 multiplied by the length 100 over the diameter, which is 0.2 meter, multiplied by B square 1.27 square divided by 2 by G, which is 9.81. So we get the head loss equals 0.83 meter. This is the head loss. We simply found the velocity from Q over A and substitute the numbers directly into Darcy-Weisbach formula. So this is about today's video. If you have any questions about any of the problems we solved here, please send me a comment. If you have any question you need help with to solve, please also you can send it to me in the comments, and I will address it in the upcoming videos. Thank you for following my channel, and I look forward to seeing you in the next video.